and you can share what you got. Remember, it's okay to be wrong. I didn't teach you guys this stuff before I sent you home to try and figure it out on your own. So learning it right now is completely fine. Fixing your answers as you go along and asking questions as we learn and reinforce this stuff is what we should be doing. So I want to bring you back to first year biology, high school biology, okay? Earbuds out, pause your videos. You're looking at your homework. You're looking at this, okay? Either digitally or on paper. So do you guys remember when we did this lab? This lab had those clear jelly-like cubes that were different sizes. And then we soaked them in that red phenolphthalein. And we let the material diffuse into the cell. And then we measured the depth of diffusion, okay? Why did we do that? We did that to help illustrate the surface to volume ratio, okay? If you did not have regular biology in this school, so you didn't do that, there's videos on Google Classroom to familiarize yourself with this lab. This lab is actually an AP lab, but we do it in first year biology and high school biology because we're awesome. Okay, so we're not going to do it again since you guys did it, but I want to refresh your memory on those concepts, and we're going to bring in more math now than we did in regular biology, okay? AP classes have the math tied in there as well, so you can tie that into your logical thinking. All right, so I redid this sheet so that we could type on some of it. Some of it you needed to get creative with it as well. All right, first question, why do cells need to be a variety of shapes and sizes? Start us off. Oh, Brooklyn, did I not check your homework? Oh, I'm going to just check Brooklyn's homework real quickly. She doesn't have any points. She wants points. So, do that real quickly, and then we can comment on behalf of the first one. Thanks. Okay. So can you answer that first question for me, Brooklyn?
So they can perform different and specific roles in organisms?
Right. All cells have different roles in the organism that they are a part of. So, you know, if the cell played a role in diffusion, it might be thin and long. If it played a role in protection, it might be thick. So they need to be different shapes and sizes. They are not all the cartoonized biology animal cell, a plant cell, right? They're very, very diverse in all organisms. All right. So the next thing that we need to do is we need to talk about cell size and shape. So the first one, it says, we're both cell A and B, and we're talking about these. Is it the original document that I plagiarized to make it a little bit more digital for you guys? I just admitted plagiarizing. For education and for not-for-profit purposes, they probably won't put me in federal prison. All right. So what we want to do is we want to look at those cells. One of them's round and one of them's ellipsoid. And we want to answer this question. We want to know the rate of 100 molecules per centimeter squared per minute. We need to calculate the total number of oxygen molecules that would enter in a 5-minute period. So start us off with that one. Jason, how did you calculate that number?
Well, I took the surface area and I multiplied it with 100 molecules and I multiplied it by 5.
Okay, so we took the surface area. What is it for cell A? What does it say up there?
12.5.
12.5. Good. Can I see where I'm writing? Yeah. And then he said he did it, multiplied it by 5 minutes, and then he multiplied it by 100 molecules, right? And then what did you get, Jason?
I got 6,250.
Perfect. Yeah, 6,250 is what you should have gotten. You needed to get these questions right in order to answer the next 2 questions, okay? So if you got these wrong, go ahead and write down the correct answer. Now that you know how to solve that, you could do it for cell B, okay? Hannah, can you tell me what you got for cell B?
9,800.
Okay, and you did it the same way. You took the surface area, multiplied it by 5 minutes and 100 molecules, and she got 9,850. Is that what you said? Okay, good. Now we need to take We need to use that and calculate the number of oxygen molecules available per centimeter. Sorry, this is a typo. Can you make that say cubed? I didn't add that 3 there when I was retyping this document. Can you put that in there? So it's a volume, so volume should be centimeter cubed. Sorry about that. During the 5-minute period. How might I solve that? Raise your hand for this one in case you got the top wrong. You might not have done this correctly. Kenny, talk us through that one. How did you do it?
I just divided it by the volume.
Yeah, so for the first one, you took your answer for cell A, right? You took the total number of oxygen molecules, which was 6,250, and you divided it by the volume. Can you tell me what the volume is?
4.2.
4.2 centimeter cubed. And what did you get, Kenny?
1,488.
1,488. Raise your hand if you got that as well. Okay. Boop, 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 boop. All right, so for cell B, what did you get for cell B? Carter?
I got 2,280.
I got,
Or did I mix it?
what did you use for, oh. What did I do wrong, you guys? Is this what you guys got for this one? 9,850? 9,850 divided by 42. I did not get what Carter said, but maybe I did it wrong.
I might have done it wrong.
You did it wrong?
I might have.
We both might have. We're close, but let's just make sure. 9,850 divided by 4.2. Oh no, 42. Right? No, it's 4.2. It's 4.2. What'd you get?
2,345.
That's what I got as well. Okay, so that is the number of oxygen molecules available for the volume during the 5-minute period. Okay, math is great, right? But what does it mean? Okay, so cell A, I'll put the pictures of them right below. Cell A is the round one. Okay, cell A allows that to get 1,488 molecules in 5 minutes. Cell B is the ellipsoidal one, and that allows us to get a lot more, right? Not quite twice as many, but it's just its shape. Everything else is the same volume, but its shape is the reason why it's able to get a lot more oxygen molecules. That's the point of the math, right? So we can look at a biological concept and we can say that if we increase surface area, we get more diffusion, but if we add math to it, then we've proven that concept. Does that make sense? So you can prove concepts in biology. Surprise, surprise. Never did it before in first year biology, but we can do that. All right, let's go to the next page. On the next page, we're going to calculate. You guys are, now you can go back to, is this algebra? I'm not a math teacher. I don't have any, I took math classes, but they were like, a long time ago, so I forget. When you're doing volume and stuff, is that algebra? Or is that geometry? Okay, so you can go back to your geometry teacher and say, listen, we proved some biological concepts because of the math skills that you taught me, okay? And you can say, Mrs. Hillmanson doesn't even know the difference between algebra and geometry. I just know how to do the math. I don't necessarily know what it's called, or at least I don't care that much. All right, so we're gonna take the surface area, we're going to take the volume, and then we're going to compare them. So the first cube is done for you. What I want you to notice is that we've taken our answer, our 24 to 8. That's not right. This should say 8. Boy, I made some typos. If you notice any other typos when I was typing things up, this should say length times width times height. So make one of those heights length. Or depth. Same thing. Length and depth is the same thing. So, but you still get the same answer. Did you guys notice that? Or were you like, I know how to calculate volume, I don't need that hint, Mrs. Hillmanson? You guys are giving me nothing. No head nods or anything. Ashley's just laughing back there at all my typos. All right, so what I want you to do, sometimes students don't do this, what I want you to do, let me make it a little bit bigger for you, is I want you to take your final area, your surface area to volume area, and I want you to make it to 1. So reduce it, or what do you guys say? You guys say simplify it, right? Simplify it to be something to 1. Okay, so I did that here for you. So 24 to 8 is 3 to 1. We're going to do that for the others as well. Okay, why are we doing that? So that we can compare apples to apples. So we can see what happens when we have surface area to volume, and to make sure our volume is all the same, we can see what the trend is with surface area. Does that make sense? So we can use the math, and it's not just a bunch of weird numbers. All right, tell me what you got for your 3 centimeter cube, please. Everybody yell out what you got for that number. Everybody yell it out now.
54.
54 for that one. And the units for that are centimeters cubed. Feel free to write those in. Numbers in science always have units. What did you get for your volume here? Everybody yell out what they got. It's okay if you're wrong, yell something. 27. Now that brings us to 54 to 27 for our ratio. Now here's the kicker. Let's reduce that, or simplify, you guys say, right? I was told that you guys don't say reduce. You say simplify. Simplify that for me. Jason, can you simplify that?
2 to 1.
2 to 1. Thank you. All right, now we do our 4 centimeter cube. This should say 6. I'm just trying to talk and write at the same time. Our 4 centimeter cube, we take our surface area times our 6 sides. What did you get? Yell out your number for here. Everybody yell it out.
96.
96 is what I got as well. And now for our 4 centimeter cube, oops, that should be 3. I really can't talk at the same time. 4 times 4 times 4, what is that? Yell it out. 64. That brings us to our ratio of surface area to volume. Now this one's a little trickier to reduce to something to 1. Raise your hand if you want to take a guess, knowing it's okay if you're wrong. Ashley? 1.5 to 1. Maybe you already did it to 3 to 2, and now you know that it's 1.5 to 1 because we want to make it all the same so we can compare them. All right, for our 5 centimeter cube, to calculate surface area, we take the sides and we multiply it by 6 for each side of the cube. We take the measurement, multiply it by 6 sides. What did you get for this? Yell it out.
50.
You guys can't mumble, otherwise I have to call on people. What did you get?
180.
That's right. And now we want to take our volume, length times width times height. What did you get for that one? Yell out your guess. Okay if you're wrong. 125. That brings our ratio of 150 for our surface area to 125 for our volume. Convert that to a ratio that is something to 1. Raise your hand if you want to take a guess, knowing it's okay to be wrong. Triumph. 1.2 to 1. Now we have our numbers. Now is when we analyze and think about our numbers, okay? So this is our 2 centimeter cube. This is our 3 centimeter cube. This is our 4 centimeter cube. And this is our 5 centimeter cube. As we get bigger, what happens to surface area? Yell out more or less. As we get bigger, we have less surface area, right? We do. As cells get bigger, they have less surface area, okay? So that's why cells are small. That's why an elephant doesn't have bigger cells. What does the elephant have? More cells, right, okay? Perfect. Let's use this data and we'll graph it, okay? Made a graph on the new one. Remember your graphs. You will be asked by the College Board to make graphs based on information. And then you will have to upload. That's a great way to ask one question and to assess lots of your skills. I think that they had at least 2 graphs on that 75-minute test last year. Hopefully you guys will have ability to take it written and not have to do it remotely, but you never know. Prepare for both. So you could write out all your graphs on paper, take a picture, and then upload that image, scan it, upload it, whatever you want to do. You can create it digitally using docs, using sheets, lots of different ways. You could have another program where you can make graphs. This is stuff you got to nail down. So as we plot all of our volume and our surface area, if I was grading students on this, I would grade the accuracy of the line graph, right, and the plotting of the points. You get points for labeling your X and Y axis. I asked you to label your X and Y axis, not with just words, but with also the numbers, okay? So make sure you always label your X and Y axis. That's how you get points. I would strongly suggest always putting a title. This shows that you know what you're graphing. So let's look at this trend. As volume increases, surface area increases too. We can clearly see that. Now there's a question here, number 3. Explain what happens to the ratio of surface area to volume with increasing size. What did you say for that one, Emma?
The ratio between the surface area and volume increases with cell size increases.
Okay, good. She said volume, surface area decreases as volume increases, right? You could have flipped it around the other way and said the opposite, but you're essentially saying the same thing, okay? So increasing size leads to less surface area. Okay, you don't have to write the same thing I have. If you have something similar, you're fine. The next question said, it does say explain what happens, but it doesn't say why. I put the why. I think that an AP question would have the why afterwards, right? And the why is, can someone tell me why? You didn't have to put it down there, but why? If we have smaller cells, do we have more surface area? Why is that a good thing? Someone explain? Why would we want smaller cells with more surface area? Kenny?
So we can get more oxygen and nutrients faster.
Yeah, so that they can survive, so they can get what they need faster, they can metabolize things faster. Perfect. Next question says, what increases the fastest with increasing size? Volume or surface area? We're going to do the yell out game. I'm going to repeat the question, and you're going to yell out your guess. You had a 50-50 chance, and I don't care if you get it wrong. You just want to still yell out the right answer, yell out whatever answer you chose. Here's the question again. Think about it. What increases the fastest with increasing size? Volume or surface area? Yell out your guess. Volume. Oh, wow. Nobody got it wrong. Sometimes people confuse those. They confuse what it's asking. I don't know why, but sometimes students switch those. Volume is what you should have for number 4. Okay. So now this is where we do the lab that helps us visually see surface area to volume ratio. Let me put it right in the middle. So if you don't remember doing that, watch the videos that I posted to Google Classroom. But essentially, what we have is I'm going to get a blank one so I can rewrite on it. We have agar cubes, those little gel-like cubes, gelatin-like cubes, and we're soaking them in a phenolphthalein dye. And then I had to write a hint in because otherwise students are a little confused. My hint here was all cubes had pink diffuse about 0.25 centimeters in depth. And I know that your math teachers always put a 0 in front of that, don't they? It's like math teachers started doing that like 10 years ago. I'm like, oh, that makes sense, but I don't do that. So sorry if I don't put a 0 in front of my decimal point. I probably should. That's probably good practice to avoid confusion, right? Okay. So if we had a diffusing in 0.25 from each side, remember that that will play a factor in this measurement, right? In case you guys are unsure. So cube number 1's total volume is 1 centimeter, right? So what is the total volume of this cube? Remember, length times width times height is, it would be 1, right? 1 centimeter. Good. Cube number 2 is 2 centimeters on one side. So what would its total volume be? Yell out your guess. 8. Cube number 3 has a side that is 4 centimeters. So what would its volume be? 4 times 4 times 4 is 64. Okay. So now we have to figure out how much of that volume is not pink. And you need this information that I've starred up here to figure that out. Okay? You're supposed to be able to measure on this worksheet, but the problem is that they made it sort of like a 3-dimensional picture. So this depth looks bigger than it should because it's supposed to be like a 3D picture. Okay? So that's why I had to give you that hint to help you out. So if each side had 0.25 diffusing in, so we have 0.25 diffusing in on one side and we have 0.25 centimeters diffusing in on the other side, how much of this have we lost? we've lost half of a centimeter, right? 0.25 on one side, 0.25 on the other side means that the internal volume as a whole has lost a half a centimeter. 0.25 plus 0.25 is a half a centimeter. Good? We need to know that. So now how much is left? If we've lost half of a centimeter from our 1 centimeter cube, how much is left in the center on each side?
Half a centimeter.
Half a centimeter. Good. Now that we know that we have half a centimeter left on each side, let's figure out our volume of the part that's not pink. Use your calculator if you need to. 0.5 times 0.5 times 0.5, length times width times height. What would that be, Carter?
For the
Volume of the not pink.
7.5.
Nope. 0.5
Oh,
times 0.5 times 0.5. Punch it into your calculator really quickly.
Oh.
See what you get. You got it, Jason?
0.125.
Yeah. Look, I wrote a 0 in front of that. You proud of me? It is so much clearer. It really would be a good habit for me to get into. I'm too old to start new habits, though, Hannah. Sorry. All right, let's do the next one. We have a 2 centimeter cube, and we have lost a total of a half a centimeter on one side. So what is the side that is not pink? Start us off with that so we know how we're getting there. What do you think for that? Peyton?
3.375.
Yeah, you're giving me the final answer, but I kind of want to explain how we got there. So each side is now, how much is not pink on each side?
1.5.
Yeah, 1.5, and then to get that answer that Peyton just gave, he did 1.5 times 1.5 times 1.5, and he got 3.375. Okay? Last one, how much is not pink on each side, Anthony? It's a 4 centimeter cube. We've had a depth of 0.25 diffusing on each side, so how much is not pink?
I think I might have done it wrong.
Well, let's take a look at this and let's just figure it out then, okay? So this whole length, before we soaked it in the pink, was 4 centimeters. The pink soaked in 0.25 on each side. So how much did we lose of that side then? We lost 0.25 on each side, so how much total was lost from the middle?
Like 7.
What's 0.25 plus 0.25? Right. So we've lost a half of a centimeter from this 4 centimeter length. So how much is left that's white now?
3.5.
Right, 3.5. So if each side has 3.5 left that is not dyed, we take length times width times height to get our volume that is not pink. Punch that into your calculator if you did not do it beforehand. And what do you got, Emma? 42.8. Are you getting that? Nod your head if you got that. Okay, good. You gotta be able to do this on your own. This is the last time that I'm teaching you before the test. Okay, or before the AP test. Now we have to figure out how much of the volume is diffused, right? It tells you how to do it right here, right? You take your original volume and you subtract the volume that is not pink. That would be our diffused volume, right? So we take 1 minus the volume that is pink. Do that now if you did not. And what do you have for that? Braden? 0.875. Is that what you said?
Yep.
Good. Awesome. And now, what do we have for this 2 centimeter cube? What did you get for that one, Hannah?
4.625.
Yeah, it's a lot bigger. 4.625. And what do we have for our 3 centimeter cube? Lamb? 21.2. Good. Now we have to figure out what percentage of this is diffused. You figure out percentages by taking the whole and taking the part over the whole, right? So the part that diffused is this part right here. The whole is the top one. So 8.75 diffused volume out of a 1 volume. Would that be a passing score? right? Sometimes people know how to figure out percentages because they're like, oh, it's a one question test and I got 0.875. Am I passing? What's my percentage? What do you think? Ella?
87.
Yeah, that's passing. That's almost an A. That's pretty good. Okay, now I want to take, if I got 4.625 on a quiz, it was an 8-point quiz, what would my score be? Would I be passing, Kenny? Heart over the hole.
Barely.
You'd barely be passing, right? You got a number for me?
Well, if my calculator gives me fractions, so I got 37 out of 60.
Your calculator gives you a fraction. Throw that calculator away. You don't want fractions. You can't put fractions on the AP test. Maybe you're in a weird mode or something. All right, who's got a number for this?
That's 57.
57.8. Good. Okay. I'm just going to tell you the last one. The 21.2 over 64, you should have gotten 33 for your percent. Let's look at the numbers, okay? The numbers are, as the cubes get bigger, what happens to the percentage of diffusion? Increase or decrease? Yell it out. Decrease, right? So analyze that in the last two questions. Remind me that we didn't get to talk about those, and we'll talk about those tomorrow. Tonight, you need to do those water potential problems. Try them, just like today. I want to see an honest effort, and then I'll go over them tomorrow, okay? You may wipe off your desks and crayon. I'll see you guys tomorrow. Do those Ed Puzzle videos that will help you understand water potential and practice those problems to the best of your ability.